In this video, we are going to look at average rate of change. To do that, we need to refresh our memory about slope. The slope of a line is found by taking the difference of the y values, y2 minus y1, over the difference in the x values, x2 minus x1. If we do that with these 2 points here, we could do 1 minus -4 over -6 minus 2. That is going to give us 1 minus -4 is +5, minus 6 minus 2 is -8. The slope is a measure of the steepness of the line and is also known as the rate of change. A rate of change is the measure of the change in one quantity with respect to a change in another quantity. There are two types, average and instantaneous. An average is taken over an interval, whereas an instantaneous rate of change is a change that takes place at a specific point. When a quantity changes at constant rate, the graph is linear, and when rate of change is not constant, the graph is not linear. To determine the rate of change in the second case, it requires us to calculate the slope for a curve. If we remember, the slope of a straight line is constant and is the same for every part of the line. This is not true of a curve, as some parts are going to be steeper than others. We're going to develop a method for developing the slope of a curve, specifically with average rates of change. Consider estimating the slope of the graph of the function y equals x squared at the point 3 and 9, at this point right here. Now the problem is we need 2 points in order to calculate the rate of change. To estimate the slope of the curve at the point P, we're going to choose a second point on the curve Q. So let's say Q is our point at 2 and 4, and we can label these P and Q. Then it's quite easy to find the slope of this line here between P and Q. That is just using our slope formula. We're going to have 4 minus 9 over 2 minus 3, -5 over -1 gives us a slope of 5. Now this line has a very special name. It's called a secant, and a secant is a line passing through 2 points on a curve. We can get a better estimate of the slope as we move P and Q closer together. Now let's, for example, do Q is 2.5 and 6.25. Then the slope would be 9 minus 6.25 over 3 minus 2.5. That would give us 2.75 over 0.5, which gives us a slope of 5.5. A little bit better of an estimate of the slope of the curve at the point P. The average rate of change can be determined from either a table of values, a graph, or an equation. The following table represents the growth of a bacteria population over a time period of 10 hours. The question is, during which 2-hour intervals did the bacteria population grow the fastest? If we used a table, then what we would do is calculate the change in bacteria, the change in time, and then the average rate of change. So between 0 and 2, we have 1122 minus what we're starting with, 850, which is 272. Our change in time is from 2 hours to 0 hours, or a change of 2. Our rate then would be 272 divided by 2, which is 136 bacteria per hour. Now, what I want you to do is go through and calculate each of these. So the next one we would get 359, then 473, 623, 823. Our change in time is always going to be 2 hours, because that is what is given for our intervals here. And then make sure that you get these rates. 179.5, 236.5, 311.5, and 411.5. That means that during the interval from 8 to 10 hours is when the population grew the fastest. Using a graph, we could graph this data. Starting here, we've got about 850, 2 hours, a little over 1,000. So I'm not going to do all of them here. We're quite high at 10 hours. You should get a nice curve in here. This would be time. This would be number of bacteria. Make sure you label your axes with units. Then it asks us to draw a secant line that passes through each pair of endpoints for each 2-hour interval. So for example, the first one, the secant would be here, and then you could calculate the slope for that using rise over run, and you would do the same for each of those. What you should get here is the exact same values you got in the table above. You should notice that each of the slopes are the same as the average rate of change that you calculated above, and that the average rate of change is equal to the slope of the secant line.